Hey guys, so here is your first video for the days I'm gone. This is kind of our first real lesson into standard form. We're going to do some standard form and talk about the solutions of both standard form and non-standard form in this video. And then tomorrow is going to continue to talk about solutions of standard form, non-standard form, but with decimals. Um, so our first activity is we are shopping at Royal Farms. It's 2:45 and you and your friends are dismissed from school. Y'all are hungry, so y'all decide to stop at the store. At Royal Farms, a bag of trolley gummies costs $1 and a bag of Takis costs $2. Find the cost of 6 bags of gummies and 3 bags of Takis. Go ahead and find the cost of 6 bags of gummies and 3 bags of Takis. Do this on your paper and then answer in the Nearpod. Okay. Now go ahead, do 4 bags of gummies and 4 bags of Takis. Go ahead, do 5 bags of gummies and 4 bags of Takis. Lastly, do 8 bags of gummies and 2 bags of Takis. Okay, so the way you should have done this is we know gummies are $1 each and the Takis are $2 each. That is what it told us up here in our word problem. So 6 bags of gummies at $1 each would be 6 times 1. 3 bags of Takis at $2 each would be 3 times 2. And then you would have to add them. So 6 times 1 is 6. 3 times 2 is 6. So together this would be $12. Same kind of concept down here, 4 bags of gummies. So 4 bags times $1 plus 4 bags of Takis, 4 bags times $2. 4 times 1 is 4. 4 times 2 is 8. Add those. That also equals $12. So there's a different combination in which you can make $12. Continuing on, 5 bags of gummies and 4 bags of Takis. 5 bags of gummies would be 5 times $1 plus 4 bags of Takis would be 4 times $2. Your gummies would cost $5. Your Takis would cost $8. Together, that would be $13. And lastly, we have 8 bags of gummies and 2 bags of Takis. So 8 bags of gummies times $1 plus 2 bags of Takis times $2. 8 gummies at $1 is $8. 2 Takis at $2 is $4. Add those together, that is also $12. So this one here is the only one that does not equal 12. Which means if I had exactly $12 to spend at Royal Farms on gummies and Takis, I could do A, I can get 6 bags of gummies and 3 bags of Takis. Or I could do B, 4 bags of gummies and 4 bags of Takis. Or I could do D, 8 bags of gummies and 2 bags of Takis. If I did C, I wouldn't have enough money. There's also additional solutions and additional combinations that I could do that would add up to $12. So down here, Danelise has $10 to spend at Royal Farms. Can she buy 7 bags of gummies and 2 bags of Takis for her and her friends? Explain or show your reasoning. So go ahead, work through this problem on here, and then answer it on the Nearpod. Okay, so we know that she has $10 that she can spend. We need to figure out how much 7 bags of gummies would cost and how much 2 bags of Takis would cost, and if she has enough money for that. So 7 bags of gummies times $1 plus 2 bags of Takis times $2. Does that equal 10? Okay, so 7 times 1 is 7, plus 2 times 2 is 4. 7 plus 4 equals 11. So we want to say, no, she does not have enough money to buy 7 bags of gummies and 2 bags of Takis. Okay. If you said or did something else here, that is fine, as long as you explained or showed your reasoning. So this is my complete sentence answering the question. This is me showing my work. So this is me showing my reasoning. This is just me writing a complete sentence answering the question. This is not an explanation. It is a complete sentence answering the question. This is my explanation. Okay, number 2, what combinations of gummies and Takis can Danalise buy if she spends all of her $10? So she's spending all $10. We're not leaving any money left over. I want you to come up with a combination of gummies and Takis that she can buy. Any combination you want. Okay, I'm going to do this as a table to show you that there's more than one correct answer. So I'm going to draw a little table here. This is going to be gummies. This is going to be Takis. And we know that it needs to, the price of them together should equal $10. So not the number of gummies and the number of Takis will equal $10, but the price of them will be $10. So as an example, let's just say she gets 0 gummies. She's spending $0 on gummies. That means she can spend all $10 on Takis. If she spends all $10 on Takis at $2 each, 10 divided by 2 would be 5. So she could get 5 bags of Takis. If she did 1 bag of gummy for $1 each, that would leave her with $9 left. She cannot get an even amount of Takis that will give us exactly $10. But she can do 2 bags of gummies. So 2 bags of gummies times $1 each would give us $2. She would be left with $8 from the original 10. So she can buy 4 bags of Takis. So notice these two numbers aren't equaling 10, but the price that 2 bags of gummies and 4 bags of Takis would equal would be 10. Okay. Gummies, if she did 4 bags of gummies, that would be $4. She would have $6 left, so she can get 3 bags of Takis. She can do 6 bags of gummies for $6. That would leave her with $4 left over to get 2 bags of Takis. Gummies for 8 bags would be $8, leaving with her with $2 and only 1 bag of Takis. Or she could do 10 bags of gummies and 0 Takis. Okay, so notice there is kind of a pattern here. There is a pattern here. Every time the gummies went up by 2, the Takis went down by 1. The more gummies she buys, the less Takis she'll be able to buy. And vice versa. The more Takis she buys, the less gummies she'd be able to buy. Okay? I'm going to put our word problem back up at the top and go to the next page. So if you flip to the next page, you will see problem 3. Use two variables to write an equation that represents the $10 combinations of Charlies and Takis. Be sure to say what each variable means. So this part here is very important. When you're able to write an equation yourself, you need to say what each variable is. Now, I'm going to continue to use X and Y. We are going to use X and Y because that is the common variables. But I still have to say what my X is, what my Y is. And this is where our standard form comes into place. This is what I was talking about in our warm-ups this week. So our standard form is AX plus BY equals C. So the total amount of money that Danalise wants to spend is $10. So that total is going to be my C. Then A and B is my unit rates. So my unit rates is gummies are $1 per bag of gummy, and my Takis are $2 per bag of Takis. So my unit rate is going to be $1 times my X. If we go back to the beginning, I was doing the number of gummies times 1. So X is the number of gummies plus my second unit rate, $2 per bag of Takis, would be 2 times Y. And again, on the front, we were doing the number of Takis times 2. So Y is the number of Takis. Okay, so this here is my standard form equation. What I told you guys throughout this week, none of these numbers, not the 1, 2, or 10, none of them are my y-intercept, nor are they my slope. So we're used to writing stuff in the form y equals mx plus b, but the information in our story does not give me a starting amount that I have. It tells me my total amount I can spend, but it doesn't tell me how much I have, and I'm not taking away from the $10. I'm talking about how many gummies and Takis I can spend. And I have 2 unit rates. If you have 2 unit rates, you're going to use that standard form. So I have $1 per bag of gummies, and I have $2 per bag of Takis. So those are my 2 unit rates. This is my total. Okay, so number 4, what are 3 combinations of Charlies and Takis that make your equation true? What are 3 combinations of Charlies and Takis that make it false? So the ones that make it true is what we had in the beginning. And I'm going to show you how to use this equation to figure that out, or to prove it. So we're going to do our true ones on this side and our false combinations on this side. So if I'm using this equation here, and in our table on the front, we said, for example, 0 bags of gummies, 5 bags of Takis. I can put 0 in for X, 5 in for Y, and see if it equals 10. So if I do 1 times 0 plus 2 times 5, so this is $1 times 0 bags of gummies plus $2 times 5 bags of Takis. Does that equal 10? Well, 1 times 0 is 0, plus 2 times 5 is 10. Does 0 plus 10 equal 10? Yes. So that is a combination that does work. 0 bags of gummies and 5 bags of Takis. Okay, another one that we want to try and prove if it is correct. We can do 4 bags of gummies and 3 bags of Takis and test that out. So if I put 4 in for X, my bags of gummies, so 1 times 4 plus 3 bags of Takis, so 2 times 3, we're putting 3 bags of Takis in for Y. Does that equal 10? 1 times 4 is 4. 2 times 3 is 6. Does 4 plus 6 equal 10? Yes. So my solution here is this 4 and 3. So 4 bags of Takis, sorry, 4 bags of gummies and 3 bags of Takis. And we need one more true one. We can pick any because from this table because I already kind of went over once. So let's look at just 10 bags of gummies. If we got just 10 bags of gummies. So $1 times 10 bags of gummies plus $2 times 0 bags of Takis, does that equal 10? 1 times 10 is 10, plus $2 times 0 Takis is 0. 10 plus 0 is 10, so that does work. So we can also do 10 bags of gummies and 0 bags of Takis. These are all solutions that make it true. If I was to graph this, all of those would be on the graph. Okay, so ones that would make it false is basically anything that's not in this table. So let's just try, we'll try 1 bag of gummies and 5 bags of Takis. So if I try that in my equation up here, 1 times 1 bag of gummies plus 2 times 5 bags of Takis, does that equal 10? 1 times 1 is just 1, plus 2 times 5 is 10. Does that equal 10? Well, 1 plus 10 is actually 11. 11 does not equal 10. So this is false. This is not a solution. It is not a combination that would work. Anything where your bags of gummies would be false. Oh, sorry. Anything where your bags of gummies would be an odd number would be false because you can't have an odd number of gummies since that's only $1 and our total amount is an even number. But we could also try let's try 8 bags of gummies and 2 bags of Takis. I would do $1 times 8 bags of gummies plus $2 times 2 bags of Takis. Does that equal 10? 1 times 8 bags of Takis is $8. Plus 2 times 2 bags of Takis is $4. Does that equal 10? No, that equals 12. So that is not a combination. So I want you to come up with one more combination. There are so many combinations that would not work. Come up with one on your own that would not work, that would not equal $10. Go ahead and do that on your own. Okay. Activity 2 is just talking about numbers. We are not putting it into a story. Okay, we're just going to be talking about numbers and whether it would make an equation true or not. So you have 2 numbers. If you double the first number and add it to the second number, the sum is 10. I don't like that it's 10 again as our sum. So we want to break this down. If you double the first number, so double means to times by 2. We know add is our plus sign. Sum is what it equals after adding. So that's that total. Sum means the same thing as total. So it says let x represent the first number, let y represent the second number, write an equation showing the relationship between x, y, and 10. So if you double the first number, so we're going to take x and do times 2, so 2x, and add it to the second number. Our y is the second number, so add it to y. The sum is 10. That means it's equal to 10. That is your equation there. That's going to be the equation that we work with on the next page. 2x plus y equals 10. Notice again, this is in the form ax plus by equals 10. Our b here, that invisible number is a 1. So 2x plus by 1y equals 10. Okay, so this says draw and label a set of x and y axes, plot at least 5 points on this coordinate plane to make this statement and your equation true. So our equation I'm going to write again is 2x plus y equals 10. This is very, very similar to our Takis and gummies situation. Just our x would be kind of the Takis here for $2 each, and our y times 1 would be our gummies in this situation. So, we want to kind of make a table again, x and y. If I made 0 my x, if I put 0 in for x, 2 times 0 would be 0. 0 plus y equals 10. So what plus 0 is 10? That is just 10. If I had 1x, 2 times 1 is 2, plus something is 10. 2 plus what is 10? 2 plus 8 is 10. Again, 2 for our x, 2 times 2. 2 times 2 is 4. 4 plus something is 10. 4 plus 6 is 10. So this is going to be 6. You'll start seeing a pattern. 3x, or 3 for our x, so 2 times 3 is 6. 6 plus something is 10. 6 plus 4 is 10. And it's said to do at least 5 points, so we'll do one more here. 4 for our x. 2 times 4 is 8. 8 plus something is 10. 8 plus 2 is 10. So I can now plot these points on my coordinate grid. So 0, 10, 0 up to 10. Then I have 1, 8, so I'm going to go over 1 up to 8. Then I have 2, 6, I'm going to go over 2 up to 6. Then 3, 4, over 3 up to 4. 4, 2, over 4 up to 2. And now I can connect all of these points. So remember how I said in standard form, none of these numbers are my y-intercept or slope. I guess technically in this example, 10 would be my y-intercept, but it's not always going to be the y-intercept. In fact, in the Takis and Gummies one, because my numbers were switched, it wouldn't have been. This number, don't always count on this to be a y-intercept. It's not always going to be a y-intercept. It's just because we have one y here. But our y-intercept is 10. Our slope, it's going down by 2s. It is going down by 2s. It is -2 is our slope. And you can see that in the table. These are going down by 2 every time, as this is going up by 1. And our slope is whatever the y is doing when our x goes up by 1. And then 3 says list 10 points that do not make the statement true. It says use a different color, plot each point in the same coordinate plane. So you guys can grab some colored pencils from up front. And we are writing other points that would not make it true. So another point that would not make it true, for example, would be if I had 1, 5. Okay. So if I had 1 for x, so my equation again, 2x plus y equals 10. If I put 1 in for x, 2 times 1 plus 5, does that equal 10? 2 times 1 is 2, plus 5 equals 10. 2 plus 5 is 7. That does not work. So if I plot 1, 5 in a different color, 1 up 5 is right here. That's supposed to be a different color, but you can't really tell. That's a little bit better. I'll switch to my green or something. Okay. Another point, this says to list at least 10 points, so I'm only going to do like 1 or 2 more with you guys, and you'll do the rest. Another point that wouldn't work would be if I did 7, 3. If I put 7 in for x, so 2 times 7 plus 3, does that equal 10? 2 times 7 is 14, plus 3 does not equal 10. So 7, 3 does not work. I'm going to plot that over here, 7 up 3. I'm going to do one more with you. You will do the rest. Let's do 5, 7. So I can do 2 times 5 plus 7. Because, again, 5 is my x. So I just put 5 in for x. And 7, that's my y. Put that in for y. 2 times 5 is 10. Plus 7 is not 10. So that does not work. So I'm going to plot that on my graph, 5, 7. What I want you to notice about these points is none of these points are on the line. So what makes something a solution is that point or that answer would be a point on the actual line. Anything that is false or not a solution would not be on the line. So I want you where it says, what do you notice about these points compared to your first set of points, compared to the points up here? I want you to say something that these points are not on the line. If they are a solution, they will be on the line. If they are not a solution, they will not be on the line. And then down here, I want you guys to tell me which of these coordinate pairs make this equation true. So you'll put x, the x value in where x is, put the y value in for where the y is, and solve to see if it equals 12. Does 12 minus 9 times 0 equal 12? If so, then this one works. If not, if it doesn't equal 12, then it doesn't work. Okay, so go through these points, see if they work for this equation and if it makes it true. If you guys have any questions about this, please let me know. Again, I told you guys to email me if you guys need anything, message me on Google Classroom. If you need another video or need any extra help with kind of this, let me know. Again, tomorrow is going to be kind of similar, talking about solutions. So if you get to like the weekend, you're like, I need help with this, or need help with anything before the test on Tuesday, just shoot me an email and I will respond. Okay. I'll see you guys in the next video.